I'd like to give you the answers for the Unit 2 test before you take the retakes. This problem says, suppose you are designing a short wall to go across the front of a flower bed. The wall will be built with small concrete blocks. Okay, so we're making a wall. Each block is 1 foot high by 1 foot wide. One corner of the wall will need to be higher than the others so that your dog can't jump into the garden. If I was solving this problem, I would just put an X through that paragraph. That's a distracting paragraph. There's no information in there that's important. Arthur, I'm screencasting this. In this problem, you will be calculating how many blocks you need to buy so that the wall stretches across a garden that is 14 foot long. This is where most people got stuck when they took the test, was what the question was. You're supposed to calculate or figure out how many blocks, calculate how many blocks. When you go to the store, I need to know how many concrete blocks I need to buy so that the wall stretches across a garden. Okay, so that the wall is 14 foot long. I'm going to figure out how many blocks there are for a wall that's 14 feet long. So that means that the two variables are the number of blocks and 14 feet. All right? All right, so the first couple of questions are just going to walk us one sentence at a time through the word problem that we wrote down. This is just the first sentence. Suppose you were designing a short wall that we just read out loud. Nothing's new here. And it's asking us, what does the word bed mean in this context? What does the word bed mean? The word bed does not mean a piece of furniture. In this context, it means an area of ground. Typically in a garden, because it's a flower bed. Okay, next question. The wall will need to be built with small concrete blocks. Each block was 1 foot high by 1 foot wide. One end of the wall needs to be higher. Okay, so let's imagine a wall. One end of the wall is higher than the rest of the wall. All right, so which one of these shapes has one end that's higher than the rest? Is it T or square? No, L's. L shapes have one end that's higher than the rest of it. So we can have in our picture, in our mind, a picture of this wall. Now, this was the part where so many people got stuck. Okay, the two variables were the blocks you need to buy and the length of the garden. Now, how long is the garden? The garden is 14 feet long. So the solution here is 14 feet. Okay. What is this question asking you to solve for? It's asking, in this problem, you will be calculating how many blocks you need to buy so that the wall stretches across the garden that is 14 feet long. It is asking how many blocks you need to buy. All right, so now that we have a picture of what the wall is in our mind, I can look at these walls. These are all L-shaped walls. And these are three different walls. This is wall number 1, this is wall number 2, and this is wall number 3. So you can see that the wall is growing to the right. So this has 3 blocks going this way. This is 1, 2, 3, 4 blocks going this way. This is 1, 2, 3, 4, 5 going this way. So the wall's growing, going this way. That's what's changing. All right, which one of the walls is growing so that it's one longer than this? Well, that's D. And that gives us an introduction to the first one of our variables, the length of the wall. This wall, I've got a red arrow going this way, and it says F equals 3 feet. 1, 2, 3 feet long. This is F equals 4 feet. 1, 2, 3, 4 feet. This, it's asking, what will F be for the third picture? 1, 2, 3, 4, 5 feet. In the third picture, it's 5 feet long. Next question, what value of F will you need to solve this problem? Well, remember, we were trying to figure out the wall needs to stretch across a garden that is 14 feet long. Okay, so the first variable was how long the wall is. The second variable is when we go to the store, how many blocks are we going to buy? How many blocks are in this wall? 1, 2, 3, 4, 5, 6, 7, 8. 8 blocks in that wall. How many blocks? It says, how many blocks will you need for the second picture? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the next one is 12. Okay, so which one of these is the independent or input variable and which one is the output? Well, the feet is getting longer. So as the feet get longer, you have to have more blocks in the picture. So the input, the thing that's driving this, is the number of feet. And the output is the number of blocks. Now, it says which one depends on which. Now, we have a very good word here that tells us what depends. This depends. It's dependent because it depends. So the blocks depends on the feet. This depends on the feet. The blocks depend on the feet. The reason why that is because this is the dependent variable, so it depends on the input. The output depends on the input. Okay, so let's go ahead and fill out all of these yellow things. Okay, so I've got here all of the variables that I need to label. Feet goes in, and blocks come out. Okay, so that means I can label this feet. Oh, I would put 3 E's. Feet. And down here is feet. And then this was the output here, blocks. And the output here was blocks. It's a little bit slanted. And I'm going to go ahead and answer the next question as well. I'm going to put the input, the domain variables here, and I'm going to put the range here. Okay, so the domain was, it asked us for the domain to go from 0 to 14, I believe. So I'm going to have to write really small. 2, 3, 4, 5. That's probably not going to work. Let me start at maybe 12. So I'm going to skip and go 12, 13, 14. And I'm just doing that because I'm going to run out of room here. Okay, 0 feet had, we didn't have one that was 0 feet long, so maybe let's start at 1. Actually, the first picture that we had started at 3, so let's go from 3 to 14. I'm pretty sure that's the domain. So the first picture was 3 feet long, and it had 8 blocks. Okay, so for 3 foot long wall was 8 blocks. So I'm going to just start over on this. Okay, a 3 foot long wall was 8 blocks. A 4 foot long wall was 10 blocks. And a 5 foot wall long wall was 12 blocks. Now I'm going to go ahead and turn this into a function. That's the easiest thing to do. So let's see, 8, 10, 12. That means that the pattern is increasing by 2. So the 2 is the multiplier. 2 times 3, 2 times the input. Now, so the 2 comes from this pattern. So that's plus 2 plus. So 2 times 3, 2 times 4, and 2 times 5. Now, that's not going to work. 2 times 3 is 6, and I wanted 8. 2 times 4 is 8, and I wanted 10. 2 times 5 is 10, and I wanted 12. So I have to add something additional. So this is 6 plus what to get 8? 6 plus 2 to get 8. And this is 8 plus 2 to get 10. And this is 10 plus to get 12. 10 plus 2 to get 12. Okay, so my function is 2 times the input plus 2 more. And I wanted the 14 foot long wall. So the variable here, the input is going to be 14, so that's 2 times 14 plus 2. 2 times 14 is 28. 28 plus 2 is 30. Okay, so now I'm going to put a box around my answer here. Okay, and then the last thing I need to do is graph it. So let me clear this off so that I can make a nice big graph. All right, last thing that I need to do to solve the problem is pick my domain and range on the graph and then graph it. So let's see, this should go up to 14 feet, so feet should go up to 14. I'm going to put 15. That makes sense to me. And then the other thing that makes sense to me is to count by 5s, because this is a round number like 5. So I'm going to put a line here for 5 and a line here for 10. 5 feet, 10 feet, 15 feet. Now this other number goes up to 30, so I'm going to put 30 at the top. Your graph may look different because your range may look different. That's fine. So it makes sense to go by 10s here for me. 10, 20. 0, 10, 20, 30. Okay, so let's now put our graph. So I'll put the dots on. So 3 and 8 is the first one. 4, that's still before 5, and 10. 4 is 10. 5 was 12. And then you may have a different domain. You may just go up by 1s. That's fine. My domain skips all the way to 14. 14 is 30. And then I'm also going to circle that. That's where my solution is. 14 feet was 30 blocks. 14 feet costs 30 blocks. Alright, so this video is already pretty long. I'm going to stop it there. How did I solve this problem? I identified the feet was the independent and blocks was the dependent, and then I made a table of inputs on the left, that's called the domain on this side, and the range on this side. And then I found my pattern. My pattern was 2 times the input plus 2 more blocks, and that meant it was 2 times 14 for a 14-foot wall, plus 2 more blocks at the top of the L that made 30 blocks. I put a circle here around my solution, which was a 14-foot wall requires 30 blocks.